Hello, in this video we're going to look at the properties of a normal distribution. So if you would, explain the properties of a normal distribution. Tell me the things that you know about especially about the PDF for a normal distribution. Okay, well, there's several things. The graph of the PDF for the normal distribution is above the x-axis for all real numbers. It's a continuous, one-connected piece. It has a horizontal asymptotes of the x-axis on both the extreme right and left. It's symmetric about the mean, and so the mean equals the median, but it also equals the mode in this case, so the highest point is also in the middle. Inflection points occur at one standard deviation below and above the mean, and so it becomes a bell-shaped curve. And the formula for the normal PDF is, well, in your calculator, it's normal PDF x mu sigma, which is actually 1 over sigma times the square root of 2 pi. That's all the denominator there. And then it's e to the power negative parentheses x minus mu square over 2 sigma square. Okay, and so we can graph such a thing, right? And for example, let's do an example here. Let's see, how about normal PDF? Let's go from, we want that to be x. We could do a standard normal. Let's do another one. Let's do one where the mean is 6 and the standard deviation is 2, and paste that. And if I want a good window, let's see, I need to go at least 3 or 4, let's say 4 standard deviations above and below the mean. So, well, let's see, what is that? What did I just say? I put in mean 6, standard deviation 2. So 4 standard deviations would be 8. So 6 minus 8 is negative 2. 6 plus 8 is 14. That's going to give us a pretty good looking part of the window. And I need to go, well, essentially I just need to go from 0 up to, I'm not sure how high. I bet 0.4 is going to be plenty tall enough, actually. Let's take a look at the graph and see. Yeah, we could have gone a little, not as high even. Yeah, 0.3 would certainly have been tall enough. So there's an example of a normal graph. All right, a couple other things that we kind of know about these. Approximately 68% of the probability density, the area under the PDF, is within 1 standard deviation of the mean. 95% is within 2 standard deviations of the mean, and 99.7% is within 3 standard deviations of the mean. If we do the CDF, it has a horizontal asymptote at y equals 0 on the left and y equals 1 on the right, and it's continuous and increasing everywhere. And it has 180-degree rotational symmetry about the mean, comma 0.5, and we have that. So let's actually, let me modify the graph here to include the CDF as well, and for the same one. So this would be normal CDF, and this one, so this is, we don't have to go that low, negative 20 is definitely low enough. Upper is x, and mean was 6, and standard deviation was 2, if I remember right. Okay, and if I'm going to paste that in there, and then my window I need to switch a little bit right now. I'm going to go to my standard window for these, the negative 0.2 or 0.3, let's say 0.3, and maybe 1.1 for y. And let's graph that. So we'll see our nice bell shape here for the PDF, and then we're going to see our kind of like a long skinny S shape for the CDF, kind of asymptote. They both have asymptotes on the left at y equals 0. They both have asymptotes on the right as well. The PDF has asymptote of the x-axis, y equals 0, and the CDF has an asymptote of 1. So there's the PDF and the CDF together. Okay, so hopefully you can see the symmetry there. Vertical mirror image symmetry about the mean here for the PDF. For the CDF has rotational symmetry about right there, which is an inflection point. which is also the rotational symmetry. So this part would rotate down here, and this part would rotate up there, filling back where we were. So those are some properties of the CDF and PDF of normal distributions.